Welcome to our review of shrinkage porosity in aluminium castings, one of the key solidification defects in metal casting. Solidification defects in metal castings can be categorized into three main types: gas porosity, shrinkage porosity, and hot tearing and cracks. In today's video, we will consider shrinkage porosity. Shrinkage porosity can be broadly divided into two categories: macroporosity and microporosity. It's also important to note that intermediate forms like layer porosity can occur, especially in long freezing range alloys. Let's start with macroporosity. The most recognized type of macroporosity is the shrinkage pipe, characteristically formed during the solidification of short freezing range alloys, as solidification begins along the walls and proceeds more slowly at the surface. A funnel-like cavity forms, compensating for the volumetric contraction of the metal. In a short freezing range alloy, this shrinkage cavity looks like a mirror-smooth pipe. In contrast, in long freezing range alloys, it appears more like a sponge. Next, we discuss microshrinkage porosity, which is especially problematic in long freezing range alloys and low temperature gradient conditions. These scenarios create a significant pasty zone during solidification, where metals of high thermal conductivity like aluminium are prone to defects. As solidification nears completion, a mushy zone with dendrites suspended in liquid forms, affecting the flow of metal from the feeder. As the metal contracts, liquid must flow through this pasty zone, leading to tensile stresses that ultimately create pores. Now, let's explore the concept of layer porosity. Initially, at solidification, the liquid phase experiences no pressure gradient. As solidification progresses, a pressure distribution develops within the pasty zone. As time progresses from an initial state of uniform pressure to a parabolic pressure curve, the tensile stress within the liquid increases due to the diminishing diameter of capillaries. Once a critical fracture pressure is reached, nucleation of a pore occurs. When a pore forms, the pressure within the liquid metal instantly drops, relieving stress. As solidification continues, the remaining liquid is then fed from both the feeder and the new pore surface, creating further pressure gradients in the liquid. Once a critical fracture pressure is reached, nucleation of new pore occurs. This process repeats until the whole of the casting has solidified. Porosity therefore occurs in a sprinkled array of fine pores, or, if the shrinkage conditions are more severe, in an array of layers. This is shown schematically here in the final casting. The dendrites tend to bridge a region of layer porosity, effectively sewing it together with closely spaced threads. As a result, layer porosity does not have a dramatic effect on tensile strength. Thanks for watching. Remember to like, comment, and subscribe.